Imagine that humans wake up one day with the sudden ability to visually perceive dark matter. No gradual evolution, no technological interface, just an instantaneous shift in perception, as if a new layer of the universe has been unmasked. The laws of physics remain unchanged, but our sensory interpretation expands dramatically. The experience would be overwhelming, beautiful, and deeply disorienting because dark matter is not a minor background feature. It is the primary structural component of the cosmos. The first noticeable impact occurs on Earth itself. Although dark matter density on our planet is extremely low compared to cosmic scales, humans would see a faint, mist-like haze surrounding everything. Dark matter permeates the solar system uniformly, so the atmosphere, oceans, mountains, and even empty indoor spaces would appear layered with a translucent, drifting texture. It would not behave like fog or gas because dark matter does not interact with matter or airflow. Instead, it would look like a stationary cosmic medium, untouchable and unmoved by physical objects. Walking through a room, people would see themselves continuously passing through a faint, shimmering background field. The second wave of realization comes when humans look upward. The night sky transforms instantly. Instead of blackness between stars, there appears a vast, glowing framework stretching across the heavens. Dark matter in the Milky Way forms a massive halo extending hundreds of thousands of light years beyond the visible disk. To someone able to see dark matter, Earth would seem suspended not in empty darkness, but in a colossal, softly illuminated sphere, a ghostly shell enveloping the galaxy. This halo would likely appear as a diffuse bluish or violet glow, depending on how the hypothetical visual system translates dark matter density into color and brightness. Even more striking are the cosmic filaments, the immense strands of dark matter connecting galaxies across the universe. If visible, these filaments would turn the night sky into a map of glowing highways linking distant galaxies. The Milky Way would appear tethered to neighboring galaxies through enormous, faintly luminous bridges, forming a celestial web. Rather than isolated star systems adrift in darkness, humanity would see the true cosmic infrastructure, a universe held together by unseen scaffolding. Daily life changes immediately. Astronomers would no longer infer dark matter from gravitational effects, they would simply observe its structure directly. Navigation, cosmology, and physics would be rewritten overnight. The sense of human position in the cosmos would shift profoundly. People would feel embedded within something much larger and more complex than ever imagined. If dark matter became visible to the human eye, its presence would permeate every moment of daily life. People would quickly realize that their familiar world, the world shaped by light, color, and solid matter, was only one layer of reality. The new visible layer, composed of dark matter, would sit superimposed on ordinary perception, never interacting with physical objects but always present like a grand cosmic blueprint underlying the universe. The first major transformation would occur in human perception of space and direction. Dark matter, though largely uniform near Earth, fluctuates subtly due to gravitational curvature. With this ability, humans would subconsciously perceive areas of slightly denser dark matter fields, sensing gravity in a way that feels visual rather than physical. Instead of relying solely on balance or sight to understand spatial orientation, people would intuitively read gravitational landscapes. This could change how pilots fly, how athletes move, and how architects design structures, because dark matter's visual distribution would offer new cues about the invisible forces acting around us. In science, the implications are even more dramatic. The biggest unanswered questions in cosmology: how is mass distributed? How do galaxies form? What lies between them would become directly observable. Astronomers could literally look at the structure of the Milky Way's dark matter halo, identifying regions of varying density, voids, and filament connections. Telescopes would no longer need to infer dark matter from rotation curves or gravitational lensing. Instead, they would calibrate lenses and sensors to capture higher-resolution dark matter visual data, opening a brand new field of dark matter cartography. The transformation of human psychology would be profound. Before this hypothetical shift, humans view the night sky as an expanse of emptiness punctuated by stars. Suddenly, that emptiness is gone. The sky becomes dense, structured, almost alive, filled with colossal arcs, flowing filaments, and luminous halos representing the true architecture of the universe. Children would grow up with a fundamentally different sense of cosmic belonging. The universe would feel interconnected rather than void-like, with humanity visibly embedded in a vast network of glowing structures. Even religious and philosophical interpretations would shift. Many traditions describe invisible realms or hidden forces shaping reality. With dark matter now visually apparent, people might conflate scientific discovery with spiritual symbolism. The universe's unseen skeleton now vividly on display could be interpreted as evidence of cosmic design, fueling new schools of thought that merge physics with metaphysics. Navigation and mapping industries would also enter a new era. Although dark matter does not offer physical boundaries, the visible filaments and density patterns could serve as cosmic landmarks. If humans could see dark matter directly, the visual transformation of the universe would be unlike anything previously imaginable. What we currently perceive as empty space would become a vast, luminous, interconnected structure revealing the true scaffolding on which all cosmic matter hangs. Every direction, every horizon, every region of the sky would be filled with patterns, shapes, and flows that redefine how the cosmos appears to the naked eye. The most striking feature would be the cosmic web. Today, it exists only in simulations and gravitational models, but with visual perception, it would dominate the night sky. Instead of scattered points of light, humans would see enormous dark matter filaments stretching across space like glowing strands of silk. These filaments can span millions of light years, and, if visible, they would arc across the sky, gently curving like celestial rivers. Some would appear thick and bright, marking areas of high dark matter density. Others would look faint and wispy, revealing the delicate boundaries of cosmic voids. Each galaxy, including our own, would sit within a dark matter halo, appearing as a massive glowing sphere or cloud enveloping the visible stars. From Earth, the Milky Way's halo would fill much of the sky, an enormous shimmering sphere far larger than the luminous band of the Milky Way itself. Humans would instantly grasp that the galaxy is not a flat disk, but a vast structure embedded in an invisible ocean of matter. Looking outward, neighboring galaxies like Andromeda would appear not as lone spirals, but as glowing beings encased in their own halos, with filamentary bridges connecting them to the Milky Way-like cosmic tendons. Black holes would become visually identifiable by the distortion they cause in dark matter flow. Instead of an invisible singularity, humans would perceive swirling currents or vortex-like depressions in the dark matter field, revealing their locations even in regions where no light escapes. The centers of galaxies dense with black holes and dark matter would shine with intense visual turbulence, providing a direct view into the most extreme gravitational environments of the universe. Globular clusters, dwarf galaxies, and rogue stars would also gain new identity markers, each surrounded by mini halos that make them stand out against the background cosmic web. Empty space would no longer appear empty. Even regions between galaxies currently visualized as black voids would glow with faint traces of dark matter, giving the universe a textured, layered appearance rather than a sparse one. Astronomers would gain unprecedented clarity. The distribution of dark matter would reveal the true shape of cosmic evolution, showing where galaxies are forming, merging, or drifting apart. Humans could identify hidden structures, dark galaxies composed almost entirely of non-luminous matter by their halos alone. The entire scale of the universe would feel visually comprehensible. If dark matter became visible, the shift would trigger the most dramatic scientific revolution in human history, one that surpasses the invention of the telescope, the discovery of relativity, or the decoding of DNA. The ability to see the universe's hidden mass would collapse centuries of theoretical uncertainty and permanently redefine humanity's understanding of physics, cosmology, and our place in the cosmic order. The consequences would ripple through science, technology, culture, philosophy, and even geopolitics. The first transformation lies in fundamental physics. Currently, dark matter is inferred through gravitational behavior, leaving its nature a mystery. With direct visual access, scientists could examine its structure, flow, and density with unprecedented precision. Patterns revealed in the cosmic web might expose clues about dark matter-particle interactions, potentially leading to a unified model of gravity and quantum physics. Regions of varying density could highlight unknown forces or reveal exotic phenomena such as dark matter vortices or streams previously invisible to all instruments. Physics textbooks would be rewritten, and long-standing barriers such as understanding the true shape of spacetime could dissolve. Technologically, the ability to see dark matter would open an entirely new industry: dark matter mapping and navigation. Spacecraft could navigate deep space using visual cues from dark matter filaments and halo gradients, much like ancient sailors followed stars. These structures, stable on cosmic time scales, form natural highways that could guide long-distance travel. Missions beyond the solar system would rely on visual dark matter charts instead of star maps alone. Artificial intelligence systems could analyze dark matter density variations to predict gravitational anomalies, aiding spacecraft in avoiding hazards near black holes or dense clusters. This new perception would also accelerate the search for dark matter-based engineering. Understanding the structure and stability of dark matter may inspire attempts to manipulate gravitational fields or harness dark matter interactions for propulsion, shielding, or even energy generation. While speculative, such technology would represent a leap comparable to harnessing electromagnetism. Culturally, humanity's worldview would undergo seismic change. No longer would space appear as a silent abyss. Instead, the universe would be seen as a crowded, interconnected network filled with glowing filaments, halos, and gravitational shapes. Art, religion, philosophy, and storytelling would evolve around this new visible reality. Mythologies might re-emerge with fresh interpretations depicting the cosmic web as a divine architecture or metaphysical fabric. The visible presence of unseen matter surrounding every person could influence existential thought, dissolving the psychological barrier between visible and invisible reality.